Okay, guys, so hopefully today is an easy day because this should be review. So Miss Potts says that if you still have your theorem book, this was chapter 7 from Algebra 2 in your theorem book. So you may want to go back and take a look at that. So we're talking about log functions, which are inverses of exponential functions. So that's important to remember. So if I'm looking at an exponential that looks like this is my base and this is my exponent, right? So over here in log form, this is my exponent from my exponential form. And this is my base, right? So base is still a base, so it's log base A. And this is my base, which is an A, so that stays the base. One thing to remember here is that x is always going to be positive. So you can't do a log of a negative number. So x will be positive. That's important to remember. So when I'm looking at a problem like this, so this is asking me to change to log form. So I'm in exponent form and I'm going to log form. So in this one, this is going to be, I'm going to write my log first and then put equals at the end, just because I think it's easier. So it's log, and then my base is 3. And that's going to be I'm sorry about said equals, of this 1 over 81 equals that exponent, negative 4. So my x value in this case was 1 over 81. My base was 3. My y was negative 4. Okay, on this one, I have a log of base c of d, and that's going to equal my exponent p. On this one, I've got a log. This time my base is 7. And then this is of 100p. I'm going to put that in parentheses so I remember it's the whole thing, equals my exponent of x. This one, I have a log base 3 of p over f equals that negative 2x. So all of these are kind of messy, but it's just getting you used to the idea of writing it in log form. So this one is a log of 3 of my 243, and that's going to equal, again, my exponent of 5. Okay, last one of these, log of base 0.9, which is a little odd, of 1/2. So again, I think I'll put that in parentheses just to make sure it's separate there, equals my t. Okay, so that was going from exponential form to logarithmic form. Now I'm going to go from log form to exponential form. So I'm going to do the opposite. So on that first one, I have, remember to keep it your base, right? Your base is going to be the same. So my base is still a 3. My exponent is this piece over here, so to the 4th, equals this value, 81. Okay, this one would be a 4 to the exponent of negative 4 equals 1 over 256. And those are true statements. Hopefully you know that those are true statements. This is the same thing as 1 over 4 to the 4th, which is 256. This one, my base is v. My exponent is q, and it equals w. This one, my base is 6. My exponent is 3, and it equals my 2x minus 1. Now this one is kind of unique compared to these other ones. I could solve for x here. I could go ahead and take 6 to the 3rd power and then add 1 and then divide by 2 if I wanted to. So we'll get into that in a minute. For now, I'm just going to leave it like that. This one in exponential form, so I've got my base of 4, and my exponent is 5 minus x, and that equals p. This one, I've got my base is a. My exponent is 3/4, and that equals 343. Okay, so hopefully you get used to those. Now you've done this before, like I said, but I definitely think you could have used that reminder. So make sure that you go back and practice some of that. Okay, so then we get into some solving. If they say to solve for t, we can use all of those log rules to help us out. So this one, the first thing I would do is divide by 3 here. So that gives me that a to the 4t equals 10/3. Then I have this base to an exponent equals some number. I can actually write that in log form. So this is the log base a of 10/3 equals 4t. Okay, so that means if I divide both sides by 4, that gives me 1/4 the log base a of 10/3 equals t, and then you can stop there. So we know that t equals this stuff. So I'm just going to stop there. Okay, this one, kind of the same idea. I would subtract d. So f minus d equals b a to the t. And again, I would divide by b because I really want this a to the t by itself. So f minus d all over b equals a to the t power. So I would write that as the log base a of that f minus d over b equals t. And my goal was to solve for t, so that allowed me to get t by itself. So I am done. Once t is by itself, I'm done. Okay, couple of properties that we need to talk about. So this first one, the log base a of 1 is 0. The reasoning for that is because a to the 0 power, or anything to the 0 power, is 1, right? So if I had this situation, log base 3 of 1, that equals 0 because 3 to the 0 power equals 1. So these are equivalent statements, so they can say that this is true for any a value. This one, log base a of a is always going to be 1. Can you get that, babe? That is because a to the first power is a. Sorry, my phone is ringing. Okay, so the reason for that. So let's go back to log base 10 of 10, for example, is 1. Sorry, hold on a second. Who was that?
It was David. She sent you an email.
Okay. Okay, sorry guys. Okay, so one example of this was log base 10 of 10 is 1. And why is that? Because 10 to the first power is 10. And you could do that with any number. So they're saying that's true for all values of a. Okay, example 3 here. So log base a of a to the x equals x every time. Why is that? Because a to the x equals a to the x. So here's an example of that. If I had, let's say for instance, if I had log base 2 of 8, that's going to equal 3. Why is that? Well, that's because 8 is the same thing as 2 to the third power, right? And we know that 2 to the third power equals 2 to the third power, right? So that's where this comes from. 8 is the same thing as 2 to the third. 2 to the third equals 2 to the third. So this is true for all values of a and x in this case. And then this last one, if I have a to the exponent of log a to the x, log base a to the, or log base a of x equals x. So here's why. Log base a of x equals log base a of x, right? So if I had 5 to the exponent of log base 5 of 7, I should get 7, right? So let's think this through. That means I've got log base 5 of 7, which equals log base 5 of 7, right? It equals the exponent. Okay, so those log rules apply for these properties are kind of made up because of all of these other rules that we talked about. They follow the rules that we've already talked about. So this is true for every value of a and every value of x. Same thing for all of those. They work for every a. Okay, so the last couple things I'll talk about in this video. Common logs are base 10. So if they give me just log of x, it is assumed that there is a base 10 there, and that is true for every positive value of x. Same thing with natural logs. So that's the inverse of this. Are exponentials, right? So e to the x. So this is our natural exponential. So log base e of x is equal to the natural log of x. So this is a really important rule that we can use later as well. So and that's true for every value that's greater than 0, so positive x values. Okay, so this first example here, log of x equals 2. So we are assuming that they mean log base 10 of x equals 2. So what that tells me is I have 10 to the second power equals x. So my base 10, here's my exponent, equals this. Well, that means 100 equals x. So I can just solve it like that. Okay, a natural log one. This is the same thing as saying log base e of x equals 2. So I just rewrote it using this rule. Okay, well that means e to the second power equals x. So that's my answer. X equals e squared. This one, the log of z equals y plus 3. Well, that means there's an assumed base 10 there. So that means 10 to the y plus 3 equals z. And I'm just going to stop there. There's not really much else I can do with that one because of the variable and the exponent. So I'm just going to stop there. The last one, I have a natural log one again, like this one. So I'm going to say that this is log base e of z, is what I'm talking about, equals that y plus 3. So I'm using this rule again. Okay, so that tells me that e to the y plus 3 power, which I'll put in parentheses just to keep separate, equals z. So I've solved for z like that. Okay, so I'll stop there and we'll do some more practice in the next video.